Hello, all. Welcome to our channel. So, we have been talking about high-speed designs, right? We have talked about the impedance matching techniques, and then we also talked about some of the noise generating things on the board. We'll continue our discussion on high-speed designs, and in this video, we will just talk a few minutes on the measurements that are done on high-speed design. So basically, we are going to talk about the tools which are used for doing those measurements. The first thing is, while the design engineer's challenge is to um, design a board which works from the functionality perspective, from the reliability perspective, from the conformance to the specifications perspective, whatever. So a tough challenge lies in the hands of the designer. While he does that, one of the important point is, while he designs that, he will ensure, the designer shall ensure that the design is working through the debugging, or basically the testing and then debugging based on requirement. So testing is a very important aspect of a design, of a product life cycle, and design and testing play a very crucial role for a successful product to be out in the market. So while testing this, there are several tools which are used by high-speed design engineers. While there are actually different variations of these tools, we wanted to list very high-level tools, especially the measurement tools, which are like oscilloscope, vector network analyzer, impedance analyzer, time domain reflectometer, and protocol analyzer. So, what uh, does these tools do? While we don't go into actual how these tools work, we will make another video on that. How, what for these tools are used is, example, let us assume I designed a board, and then I claim that this particular trace is 50 ohms. Okay, so and then PCB, once the Gerber is released, we will get the PCB out from the fabrication. We assemble the boards and then test the boards. Let us assume in this whole process, only at the time when designer claims that he has designed for 50 ohms, or differential 90 ohms or 100 ohms, it's only either through his simulation at that point, or through some calculations during the design phase, which he'll will be the documentation things that are available to the reviewers or the entire product team. Right now, if the product works straight away, yes, it is okay. But if the product doesn't work, and when you start debugging, when we say product doesn't work, example, let us assume we have one high-speed interface. Well, let us take a simple USB 2.0. Let's not go to gigahertz of range. USB 2.0, and let us assume it's not working. So you will check drivers, you will check any shorts for those signals, you will check the continuity of those signals. So you will do several things, right? But how do you ensure that you have routed the 90 ohm differential signals, and that might be the reason why your PCB is not working? Or if you take a RF signal, in that case, let us assume a interface working on in the ISM band. If it doesn't work, how will you ensure? So in those cases, what we do is, during the design phase itself on the PCB, we do include some traces which are called the test coupons. we call them the test coupons for measuring the impedance. So what happens is ultimately whether the problem occurs or not, whether we see issues with the board or not, what the test engineers or the design engineers do is once they receive the board, they check these coupons to see whether the 50 ohm trace matching has been implemented properly or not. So for measuring the impedance of those traces, we can use three equipments: vector network analyzer, impedance analyzer, and time domain reflectometer. All these use different techniques for measurement. And then oscilloscope is basically used for probing. So you can probe your signals and see if they are as per the requirements or not. So some people do capture a stream of bits and also analyze what's happening there. And then ultimately the protocol analyzers are always there, which come integrated with the oscilloscopes and also available standalone. Even they can be used. So likewise, in addition to this, there are other tools, special power supplies, handheld equipment. There are several other equipments available, but these are the major things, major instruments that are required. Now, while we talked about some measures the impedance, some measures the signal, some measures the protocol, some captures the protocol. So which domain do they work? So oscilloscope, as we know, it works in time domain, right? Oscilloscope could be a mixed signal oscilloscope. It could only be a digital oscilloscope. So it works in time domain. When we say time domain, what it means is when you get the waveform on the screen, right? It is amplitude versus the time, against time, how the signal is varying is seen. So such signals is called such a waveform that is seen on these devices is said to be in time domain, because the base is time. Similarly, the time domain reflectometer, even that is done in time domain, and it shows the variation of impedance. And then vector network analyzer, impedance analyzer, both of them work in frequency domain. So what it means by frequency domain is instead of measuring over a time, these equipment measure over a period of over a set of frequencies, and then they see how the signal is whether the signal is present within that frequency or not. So that's how the VNA impedance analyzers do work. So basically for these equipments, right, so while measuring the impedances, they output a sine wave, and then the amount of fluctuations that happen are measured to in turn calculate the impedance of that channel. So that's how these tools work. Whereas in TDR, they just insert some step signal kind of thing, and then measure the impedance at the after capturing the output. So that's how these tools do work. And then protocol analyzers are just like probing those signals. Like we can say a logical analyzer is one example. So in scopes we do mixed signal oscilloscopes. If you see at the top here, so the input that you see here, the terminal, other than these four analog channels, so these can capture multiple bits at a time. So there are separate protocol analyzers available, and in mixed signal oscilloscopes, you also have the protocol analyzer inbuilt along with the scope. So engineers use do different tools based on the requirements. So if you have used any other tool, any techniques that you have used, please do post in the comments. We'll be coming up with more information on high-speed designs. If possible, if we can get hold of a TDR or VNA, we'll try to post the capturing information and what are the techniques, and we'll also talk about the probing techniques for high speed signals in future videos. Hope you like the video. Please visit our channel for more videos. Please like a video, subscribe to our channel. Thank you.